Hello, grade 10s, and you know what we need to do. We need to make it maths, of course. So what we need to go through, not need to, but what we're going to go through here is sketching some graphs, because we've had, oh, look at all this other nice trig. We sketched some graphs at the end of last term. In fact, we sketched quite a few, but let's just run through a few to get us back into it. So we've got a few examples. So y equals 2 cos x plus 1. Now, what is the effect of that 2 in front? Okay, well, the effect that I think is if you had your basic cos graph, let's just have it here for reference, and cos looks something like that and carries on. What the 2 is, it's going to stretch it up. So instead of looking like that, it's going to be stretched up twice as high, twice as low, etc. So that's what it would look like. Great graph, eh? So now the second question is, what is the effect of that plus 1 at the end? Well, remember that plus q at the end of any function just moves the graph up. So we've taken that and we've now moved the graph up by 1, and I don't know, whatever, it looks something like that maybe. But we're going to have to do a little bit of work to get it. But the idea is that that graph, that looks horrendous. And not horrendous. Okay, no, I think it is. So this has stretched the thing by 2, so let's go times 2, and this thing here has moved it up by 1. So let's do this a little bit more carefully. I think my purple starting graph was good enough that if we looked at these points here, you know, it went up to 1 at 90 degrees, it was at 0, at 180 degrees, we're at minus 1, at where we here at 270 we're at 0, and then we go back up here at 360, we finish off back at 1, right? And going the other way, we've got minus 90, we're at 0. This is not the neatest diagram, is it? But anyway, so we're only going from minus 180, so we can just look at that. Now let's just go step by step. It's been stretched out by 2, so therefore it's going to go down from minus 2 to 2, but everything else is going to stay the same. And now for the last bit, let's draw this here a whole lot more neatly and say our final graph. Well, we're taking the red graph because that was the stretching by 2, and we're going to move everything up by 1. So instead of starting at 2, it's going to start at 3. And the lowest point, instead of the lowest point being at minus 2, it's going to be at minus 1, right? Amplitude is still 2 because that distance is 4. And now these bits in between, everything's moved up by 1. So at 90 degrees, we're going to be at 1 now. At 180 degrees, instead of being at minus 2, now we're going to be at our lowest point of minus 1. So the graph's going to have more that type of shape to it, right? So at 90 degrees, we're going to be at 1. And here at 180 degrees, well, 180, instead of being at minus 2 from that stretching, we're going to be at minus 1. And then, so we can go up and go, okay, so this point here is at 270, but our graph's sitting at 1, and we're going to get back to where we started, 360 degrees. Our period hasn't changed. It's not like everything's happening slower or faster, and we're back at 3. So that'll be the positive direction. And if we go off in the negative direction, well, it's just going to be the same thing up to the 180. So luckily, we know that the cos graph's nice and symmetrical. So we can just see these points and go minus 90 and, well, what is this point here? Minus 180 at minus 1, minus 90 at 1. Now you're probably thinking, well, we should show what these points here are. I agree. So let's do it. How are you going to find out what the x-intercepts are of your function? Well, how do you find the x-intercepts of any function? You make y equal to 0. So in other words, we're asking ourselves, when is 2 cos x plus 1 equal to 0? In other words, when is cos x equal to negative a half? Well, then we could just take, you know, that whole shift cos thing and go, our reference angle is shift cos of a half. Remember, always take the positive value. And that gives us, do you remember, special triangle? Or are you going to be like me and cheat and just go shift cos of 0.5 and be like, yeah, 60, I definitely knew it was 60 degrees. But well done to you if you actually drew a special triangle for that. Which means that we've got 60 degrees as a reference angle, but wait, it's not at 60 degrees. Remember, cos is negative, so whether we're going to do it from our cast diagram, and hopefully this is ringing some bells, and this is why it's actually worthwhile doing this. Our reference angle is 60 degrees, but cos is negative, which means we must be in kind of those negative quadrants like that one, and then cycling back around, and that matches our diagram. Look, this is quadrant 2, this looks here, it's in quadrant 3, and this is in quadrant minus something other. Of course, there are no negative quadrants, we're just back here in quadrant 3 again. Okay, so if that's 60 degrees, let's look at all our options and say, well, therefore this would be 60, so that angle there is 120 degrees, so that's 120, 0. Check it if you really want to. So let's go, and I don't know, I got rid of my calculator now. That was silly. Calculator, there it is. So we can go 2 cos 120 degrees plus 1 equals 0. Cool, it confirms that when we input 120, our output is 0. Okay, and so you could do it for the other. So if that's 60, let's actually do that in another color. And yes, I'm flying along because this is stuff we've done. So if that's 60, then if we go all the way around there, well, we're at 180 plus 60, so we must be at 240. Well, that kind of matches our picture, 240 and 0. Now, by symmetry, I'm just going to scribble on this and then I'm going to get rid of it. If I drew a line down here and I just focused this distance over here must be the same as this distance over here. So that was 60 degrees. That's also 60 degrees, which matches our 180 plus and 180 minus. So part of what we want to do with trig is always have the little bits of trig speaking to each other. Okay, and our last bit over here, well, this value over here, well, again, we're on a negative. So if we're going negative, we're probably going round to, what colors are left to us? Blue. We must be going kind of negative round that direction. Well, that's 90. That's 30. So there's minus 90, and we're a little bit further. So negative 120. I don't know, would that work? What is cos of negative 120? And that's just cos of 120. So yes, it'll work. So again, if you're feeling like you want to use your calculator as a crutch, just check it here, because hey, maybe we slipped up, and no, plugging in negative 120 did work. So it's just a nice way just to check ourselves instead of just checking it purely conceptually. So that's it. How are you feeling? Feeling like you're getting back into trig. I'm expecting some grumbles and mumbles. Hopefully some honesty comes through. Okay, so we've got another one to draw here, then we'll find some equations. So y equals tan x over 3. So you know what the first question is going to be. What is the effect of that dividing by 3? Well, it means that everything's going to happen 3 times as slowly. So instead of our tan graph, you remember our tan graph had our asymptotes at 90 and an asymptote at 270. And when we drew our graph, we're like, oh, cool, well, that does something like that, and carries on. And there was another asymptote at minus 90. Okay, well, if that's what our y equals tan x looks like, let's label it like good people. So y equals tan x, there's what it looks like. Now, everything's happening 3 times as slowly. So now, instead of this being the case, let's draw our graph. Let's do it over here. And our asymptotes now are going to happen 3 times as slowly. So there's going to be an asymptote now at minus 270. Instead of being at 90, it's going to be at 270. That's not a great 270. And then the next one is going to be at 270 times 3. That's a rather large number. I don't know. What is it? What is 270 times 3? Okay, well, you're better than me. 810. Okay, so this one here is at 810. So now we need to draw our graph. The shape's going to be the same. Let's do an orange. So for this one over here, this is still going to do that, but it's like, it's much slower. And then this is going to do this, and it's going to, for some bizarre reason, stop at 800 degrees. So it's not even going to make it to the asymptote. It's actually going to stop over there at 800 degrees. And no, I can't think of this being a nice special angle. So we can just go tan of 800 over 3. And that is 17. Let's call it 17. As I said, bizarre stopping point, but just the idea that it's stopping just shy of that asymptote. Here we've still got 0, 0. These things carry on forever, almost going down, but stops over there. Okay, how's that tan graph looking? Okay, lovely, lovely, lovely stuff. So I think for this next graph, because we need to do a couple of examples, let's pop that in another Edpuzzle. So I'll see you on that one while you, of course, are making it maths.